So I'm going to start recording. Okay. I need to get my polls and everything up. So just give me a second. Polls and breakout rooms. And let's do 10 like that. Okay. And let's close that. All righty. So Shivani, you just send your drafts to your partners today, and then you do also need to upload your draft to Crowdmark, but you don't have to do that by tonight. So the deadline for uploading all of your stuff to Crowdmark is Friday, and everything goes up that day. So your draft, the feedback, your partner's feedback, your final version, everything goes onto Crowdmark, but you do that for Friday. Today is the deadline. It's just so that you guys know whether or not your partner is going to respond or not. That's the purpose of these internal deadlines, because otherwise you'll be like freaking out at your partner that they left everything until the last day, and that's unfair to some of you. So the internal deadlines are just to make sure that everyone is on the same page there. Okay. No, I mean, if you sent it early, it doesn't matter. But if your partner's not responding, you might want to send them another one just to be like, hey, listen, just in case you forgot, we've got to do this. You should do this, otherwise you're going to lose marks. Okay. And by the way, I know that there was someone, I don't know if they're here today, there was somebody who left in the feedback, this was probably 2 weeks ago, but who left in the feedback that they wanted to, we were talking about whether or not you could choose your own partner. So I just want you to know that I did see that. We are kind of right now sticking with the assigned partners, but we'll reassess that after. So once we've gotten a better idea, probably next week, of how many people actually got their of how many people actually had their partners respond. Based off of that information, we'll decide whether or not we want you to, we'll let you kind of self-select partners, okay? So that's just to let you know, I did see the feedback, and we'll reassess in a bit, okay? All right, so I know, again, hopefully, I tried deliberately to plan it so that there wasn't too much that you would have to do over the reading week. So hopefully you had a chance to relax, but chances are some other prof gave you a bunch of work that you had to do, but hopefully it gave you a chance to catch up a bit and, well, maybe a little bit to catch up. I mean, theoretically, that's the purpose of the reading week, right? It's to give you a chance to catch up on a lot of work. And so that's why it's there. And we didn't used to have a fall reading week, right? It was only in the winter. So you just went all throughout the fall. So that used to be a thing. The kind of issue, though, is our reading week is so early, especially in the fall. Like we had it at the end of week 4, and then we have like 8 more weeks left straight, right? And there's no long weekends or anything like that between now and the end of semester. So we got a lot of it early, a lot of breaks early, but we kind of need them more later. And it's kind of just unfortunate how that works out in terms of the timing. Okay, so hopefully you've had an opportunity and you went through and you did some of the readings. We're finally kind of starting to work on, up until now, we've been talking about the tools that we can use with linear algebra, vectors, matrices, linear systems, and all of these sorts of things. So now we're finally going to start talking about the tools that we can use to solve them. And I want to emphasize a lot here. Okay, some students, and I have seen this, I think in high school, you all learned how to solve 2x2 systems, right? 2 equations and 2 unknowns, and you know how to do that. As we start to get into higher dimensional systems, 4x4, 5x5, 6x6, and of course they don't have to be the same, 5x7, whatever the case might be, the tools that you learned in high school become very much impractical, okay? And you don't want to rely on them. So what I have seen some students do is, for whatever reason, they kind of are unwilling to learn the techniques that we're teaching them. They try to rely on their high school techniques, and it goes terribly because all of a sudden I give you a 4x4 system on a test, and you just don't know how to handle it, okay? So we do want to make sure that you do know how to solve these things in higher dimensional cases. So that's really important. Please don't kind of just ignore it and say, oh, I already know how to solve stuff, okay? Now, the other important caveat is we're also working remotely. And because we're working remotely, you can imagine that we're not going to do a lot of, in the past, a major component of what we would do in linear algebra was, here was a linear system, do all the steps to actually reduce it and arrive at an answer. You don't need like, we're not going to heavily emphasize that this term, because you can, of course, access a calculator and do those steps very, very quickly. So I would actually strongly recommend that you find an online calculator, and you are allowed to do this. Okay, you know that for the test instructions it says, yeah, listen, you're not generally allowed to use the internet for stuff, but if you want to use Symbolab or something like that in order to solve your matrix systems, that's totally okay. And we are not, like, you won't be punished for not doing that work. Okay, and that means when school returns to non-COVID procedures, no. So I can guarantee that we will stay online for the entire year. If somehow winter is not online, we will still be online. And it would be ridiculous for me to not emphasize these things and then say in a final exam, all of a sudden expect you to do them. And I think that you guys have seen so far that we've been pretty reasonable about, aligning what we've asked you to do with what we've taught you. And so we're going to stick with that. So I don't think you have to worry about that. Okay. So anyway, so keep that in mind, but it is worthwhile. Okay, you should start practicing now with one of these matrix solvers, because you don't want the first time that you're doing this to be on a test. Okay, so very reasonably, we could ask you to model the linear system and then solve it using an online calculator. And you don't want to be trying to figure out how to use that calculator on a test. Okay, now if you're interested and you need some recommendations of what things that you can use, like personally, my very favorite thing for this is Octave. And I can show you how to get Octave. It's free, it's open source, all of these nice things. But if you want to use Symbolab or something like that, great. But start sooner rather than later. Okay, you don't want to get burned by that. Okay. All right. So I will, for any of you who still have stuff about tests and writing assignments, I'll be happy to answer that after. But let's get into our content for now. Okay, because otherwise I could spend all day just answering administrative stuff. So again, hopefully you've done some readings, and we're going to jump into this. And this is our first question. So I've given you a matrix, a nice 2 equations and 4 unknowns. And yeah, Haysam, that's exactly how you spell Octave. So here's 2 equations, 4 unknowns, and I want you to perform this row operation. Okay, row 2 plus row 1 into row 2. Which of these matrices is the result of performing that row operation? That's okay, Addie. It happens to all of us every now and then. Sorry, you guys your screen might go weird for a second. I just need to open something. What the heck? Oh, there it is. Okay, so we're at about 80% now. Again, I'm going to give you about 30 seconds to get your answers in. Chifeng, just double check what's in the term test 2 announcement, which tells you exactly what's in there, which is usually just the safest way of doing this. So in case I accidentally misspeak, I don't want to tell you anything wrong. Right. So Simple Lab can only do 10 by 10. Yeah, that's probably going to be big enough for us. You imagine I'm probably not going to give you anything bigger than that. Again, though, if you want to do Octave, Octave is pretty straightforward to use and can easily do, I think I've personally done a 3000 by 3000 matrix in there, like very, very quickly. So Octave is, you know, a very powerful, useful thing to do. Okay, so I'm going to end the poll here. And I'm going to share the results here. So we're at 62% on A with a little bit of B, a little bit of D, and you know, kind of the next biggest one being C. I am going to throw you into we're not at consensus. Only 2/3 of you have agreed on an answer. So I'm going to throw you into breakout rooms and let's see what you come back with. No? Okay, hold on. Let me. Oh, yeah, that's true. That's true. All right, just give me a second here. I'll do some more assigning. All right, I'm just going through the list. I have to kind of do it one at a time here, so just give me a sec. There you go. Oh, yeah, for sure. All right, let's pull everyone back. We'll see how this goes. Oh, yeah, okay, there it is. Andy, yeah, definitely. I mean, it doesn't matter. I mean, you know that R1 plus R2 is the same as R2 plus R1, right? It doesn't, you get the same result. Yeah, so you can definitely do it kind of either way that you want, and it's totally okay. So for example, I usually adhere to a convention where I like to say what row I'm going to replace last. Like I just put it last, but at the end of the day, it doesn't make a difference. Like it's totally okay. Yeah. No, it's totally all right. Just do whatever you want. It's unambiguous, right? Like we know exactly what it is that you're doing. I think that something you guys are hopefully all learning is that we're not like dogmatic about being super rigid in how you do things. Like, we want you to explain your answers and we want you to generally do good work, but we don't care about silly little things that don't matter. You know what I mean? Kayla, so I'm not 100% certain what it is that you're asking. If you
Okay, so
want to,
like
yeah.
in the video, like that is on the reading week,
Mhm.
one of the examples that you use, you had to get like the leading number to be like positive, but I didn't know how to do that. Like, cause you didn't show the steps, you just like went to the final answer. And so
Okay.
like the only way to get it is if you did like it in the exact like order to get like the negative one to be like one, like a positive number for.
I'm not 100% sure I follow, but maybe when I start sharing my surface, I'll like construct an example. Like, would it apply to this question? Is that what you're saying?
um I'm just saying like doesn't it have to be like in exact order? So it has to be like R2 plus R1 equals R2. Like if
Um,
you were to change it, would it be different?
yeah, if you did it the other way, you would get the same answer. So
Okay.
basically what you're going to do is you're going to add the rows, kind of think about it like this. So you add the rows and then you're going to put them in row 2, right? So if you do R1 plus R2 or R2 plus R1, you'll get the same answer either way. Now, the only time this kind of might become an issue is if you're using a minus sign. But even if it was R1 minus R2, as long as when you switch them, if you reversed row 1 and row 2, as long as you wrote it as negative R2 plus R1, you would still get the same answer.
Okay.
Does that
Is
make
there
sense?
like is there any case where like it has to be like a specific order?
Mm-mm. No,
Okay.
no, it doesn't matter. Yeah. So I have a private message saying that, one of the things that I did was, in order to keep the video short, I kind of like just went straight to RREF. Is that what you're talking about? Like, I was just like, hey, let's row reduce this thing.
Yeah.
You can check, and this is in RREF. So it's true. I did skip the procedure there because the procedure was done in, I think, a previous video. But I mean, it's totally okay. We can, set up a matrix and practice row reducing it too. So that's something that we can do if we find that, we need a lot of practice on that. So hopefully, if that happens, people will yell and we can talk about that. For sure. I'm totally okay kind of going over that procedure. Okay, so here are the poll results. Phenomenal. We came back 97% on A, with a couple people still on C and D. Let's just talk about this quickly and see what is going on here. So let's share the screen, pull up some stuff here. Okay. So again, and actually, you know what? Let's kind of like talk about what's going on here, because there is some of this confusion about the exact process or the way that you should write this down and if it makes a difference. So let's kind of just do it out. Even though we were at 90, whatever percent, 97% consensus, let's maybe just do this one thoroughly, just so that, hopefully clarify that. So this is, this is row 1 here, right? And this is row 2. So what I'm going to do is I'm going to add row 1 to row 2, or row 2 to row 1, right? The order doesn't matter there. You'll get the same thing. So when I do that, so if I do R1 plus R2, then I'm going to get 0, 3, 1, 2, 2, right? Because I'm just adding directly, component-wise, every single one of these terms. Now, hopefully you see, yeah, if I'd done that differently, actually, you know what? Maybe let me write this out even kind of longer. So I would get like 1 plus -1, 3 plus 0, 0 plus 1, 2 plus 0. And if I did it in the other order, I would definitely get the same thing, because in each of its components, you're just doing addition like you would if they were just real numbers, right? Um, and we know that with real numbers, the order that we add them in doesn't make a
Excuse me,
difference.
Professor. You missed 0 plus 2.
Oh yeah, you're right. Thank you. Yep, you're right. Thank you. 0 plus 2, and then a 2 plus 0. Thank you. And then 2 plus 0, 0 plus 2. All right, and you get the same answer either way. You get 0, 3, 1, 2, 2. Okay, so it doesn't, because real numbers don't care about the order that you add them in, same sort of deal. The matrices aren't going to worry about the order that you add them in either. Okay, so don't worry about that at all. And same sort of thing. If you write, like some people like to write, let's say we subtracted them instead or something. If you write it like this, and you want to switch the order of row 1 and row 2, right? Just be careful that you put the minus sign, oops, in the right place, right? And again, those are the same thing, right? And so it totally doesn't matter how you do that. It's, yeah, I mean, I agree. I don't necessarily, no, you know what? I would totally do it this way. I definitely, depending on like just the way I grew up, I always say, you know, when I write this, it's always that I'm going to replace the last thing. So I've definitely written it this way before. Also, to find the RREF, there isn't one correct way to do it as long as I get to the correct conclusion. David, yeah, phenomenal. Actually, that's a great point that we're actually going to hit on in some slides in the future. But absolutely, there's a whole bunch of different ways to get to reduced row echelon form. And any of them, you know, RREF is unique. So as long as you've done the correct steps, you'll always get to the right answer. And there isn't one special way of doing it. And in fact, one of the things that I really kind of want to emphasize, so hopefully that answers the question, or like for the couple of people who didn't quite figure it out, hopefully that fixes your confusion. But one thing we're going to do is we are very careful about prescribing an exact algorithm for how to compute row reductions. And the reason for that is, you know, the way that a computer solves these things is very different than how humans do it, because computers are perfectly fine to work with nasty fractions, right? The computer doesn't care. It's all the same to the computer. But for us, of course, we want to avoid nasty fractions. And so sometimes the techniques that you learn to avoid nasty fractions don't fit into that standard algorithm that a computer would use. So we're kind of specifically trying to avoid giving you a fixed algorithm in order to do things. Okay, so that's sort of the idea there. What are we being tested on if you're allowed to use online calcs? Well, I mean, a large part of it will be setting up the system, which I think is probably a more valuable thing anyway. So, you know, we're kind of more interested in if I give you a system of, you know, if I give you a model, a problem, can you create the linear system from that? Use a calculator to then figure out what the answer is. And frankly, that's how things are going to work in real life as well, right? We're not interested in whether or not you can row reduce a matrix. We have computers that can do that and are very good at it. The thing the computer can't do is take the model and create the linear system from it, right? That's kind of the more important thing. Okay, so let's look at this equation. So I'm going to give you two matrices here. So this is kind of like now the opposite problem that we had before, right? So before I gave you a single matrix and told you what row operation to perform. Now I'm going to give you the before and the after, and I want you to tell me what row operation did we perform.
Hey, Prof. Just to get the question out clear, I understand how you're asking us to, or asking us to, what's it called, come up with the situation or the system depending upon a situation given.
Say that again.
So you know how you said that you would ask us to derive a system from a situation that is given?
Sure.
Right, on the test. Why would we need the online calculators though? I still can't wrap my hand around it. Like,
okay, so yeah, so you know, for example, actually, here's kind of a good example. Have you looked at the assignment 2 that was just posted?
the writing assignment or the previous? Like,
No, so or I guess assignment 3, sorry. It was just posted today.
no, I don't think so.
Okay, so there's, if you take a look at that assignment, I think it'll give you a good idea. So basically we've given you, a collection of portfolios, and each portfolio contains a certain amount of stock A, stock B, and stock C. And we say, we want you to combine these portfolios in a way to create a new portfolio.
Okay.
Right? And so what you would do is you can actually model this as a linear system, which you can then transcribe into an augmented matrix. And then if a client were to say, okay, this is the portfolio I want, you would be able to then just plug that matrix into a linear or into a solver and figure out how much of each portfolio you should buy. So normally what you would have to do is you'd have to both model and solve this system. But right now we're saying just
skip. Okay, all right.
Right? And yeah, because you can just go and you can use a computer in order to solve it. Or in fact, do you remember, I think in the videos, the example I did was like a candy shop or something. Like, you can buy candy in one of 3 bundles. Like one has licorice in it and a certain amount of jawbreakers and stuff like that.
Yeah.
And you have to combine them in order to get, this new bundle out. And you can see that one thing I did at the beginning was to model it, and then the second thing was to solve it.
Okay.
Right? So yeah, we're just kind of more interested in the modeling here.
So then, since we're using online calculator, would we still be required to show the steps of the calculation, or can we just?
No. You can like what I did, where I just in one of the videos, or probably multiple of them, I just kind of had the system, and then I drew an arrow and just said RREF, right, and then wrote down the final answer. That's totally okay. Of course, depending on what we've asked you to do. So, for example, if we do ask you to show the steps, right? If we say put this matrix into RREF and show us how you did it, then you shouldn't just one-line calculator it, right?
Yeah.
But otherwise, yeah, it's totally fine just to write arrow RREF. Now, that being said, there's still some stuff that needs to be done there. So especially as we start talking about things like infinitely many solutions, the RREF solution isn't complete. Like you can't just read off the answers there. There's still extra stuff to do. So we are just removing one part of the overall process.
Okay, so it all depends upon the question. Just read it properly,
exactly.
I guess.
Yeah,
all
definitely.
Right.
Yeah, but you're, like I said, get used to using those calculators because they take a lot of just kind of the boring, monotonous work out of it.
Okay.
Yeah. Okay, so I think we're at 93% here, which is pretty good. Let me share the results here. Great, so we have a consensus on D, and absolutely D is the correct answer. And this is kind of a common thing that we're going to be doing, right? Which is to say, well, I want to transform things into 0, and how do we do that? So let me just share here. Why can't I? There we go. Yep, and then we'll share this. So if we look at these 2 matrices, and in particular, the only difference between these 2 matrices is the 3rd row, right? Like the first row is the same in both of them. The second row is the same in both of them. So only the 3rd row is different. And we've got 3, 1, -1, -4. Somehow needs to become 0, -5, 5, 5, like this. Okay, now in theory, there are a couple things that we could have done here. We could have added, if we're going to do this, we either have to add some multiple of row 1 into row 3, or we have to add some multiple of row 2 into row 3. Now, if we want to get 0 here, right, because usually that's what your goal is. When you're converting things into reduced row echelon form, you're trying to turn things into zeros. If I want to put that 0 there, using row 2, I'm going to have to use some sort of nasty fraction, right? I'm going to have to use like -3/2 times row 2 into row 3. So instead, it's probably easier to use row 1. And if I'm saying, okay, well, what do I need to multiply by? Let's just put a question mark here. Question mark times 1, 2, -2, -3 plus 3, 1, -1, -4 has to be equal to 0, -5, 5, 5. Again, all you have to do is really focus on any one column, but probably the easiest column to focus on is this one, right? And if I want these 2 numbers to cancel out, well, the easiest thing to probably do here is to multiply the first row by -3, right? Hopefully everyone sees that. So multiplying this row by -3 here oops, why isn't that erasing? So if I multiply this row by -3, that will turn the first column into a 0, great. And then we just need to double check that the other columns also did what we wanted them to do. And if you go down the line, we'll get -6 plus 1, that's -5, great. 6 minus 1, that's +5, great. And 9 minus 4 is +5, great. Okay, so you just kind of like, you can go down the columns and make sure that everything works out. Now, of course, this is kind of backwards to what we would normally do. Normally, you're not given the before and after. Normally, you're given the before and you have to determine the row operation, right? And so we'll actually do a slide question about that in just a second. But are there any questions about this? Is everyone okay? Let me know if you're not. Can I show the question again? Sure. I'm gonna kind of have to go back here anyway, so let's do this. So here was the question. Again, the idea is look at the two matrices. The only difference between them is the third row, right? And how can I make that third row 0? Well, I can add -3 times the first row to the third row, right? And that's gonna make that element in that first column there equal to 0, and everything else works out pretty well. So that's the idea there. Okay, no problem. All right, so let's do this one now. Okay, so kind of like the third possible scenario now is to say the following. So here I have given you a matrix, and now finally I want you to tell me what row operation I should use. Okay, so I want to make that 2 in the second row. I want that to become a 0. So what should I do? Where do you think there's a typo? Ah, yes, sure. Yeah, there is. No, I think you all figured out what it means. Context clues told you what it should say. But yes, thank you. Yes, it is up. And right, and for those of you who finish early, keep going, right? Like try to put this thing into REF and potentially RREF if you want some more practice doing that. Yes, yes, Kayla, that's, yeah, just the 2. Okay, hey, so well, you know, if you hang around a little bit after we can talk about it, I'll share my screen as I pull up Octave, and I'll show you how to use it. But you might want to just even look up a little tutorial. They're usually pretty quick tutorials to show you how to use these things, but I can show you as well. All right, everyone, so we're at 87%. Hi, Nair. Okay, we're at 90%, so let's get a couple more in. Not much, not much. I mean, yeah, I mean, it's going to be similar to term test 1. We're going to ask you to explain things, right? We don't just want the answer. The answer is not interesting. The answer is for your boss when you go to work. right? We want to know how you actually solve stuff. Is RREF on the test? I mean, just check the information sheet. Everyone, I've told you exactly what is on the test and what isn't on the test. It's in the term test 2 information sheet, which you can find on Quirkus. And again, I don't want to accidentally tell you the wrong thing and then have you come back and be angry at me. So just go check that out to get the right thing. Okay, so sweet, awesome. We're looking at 85% consensus on this, that the answer is B, and absolutely B is the correct answer. Okay, so, and this is critical, okay? Like, you all need to be able to do this step, because this step is, of course, so important if you're actually doing any solving of a system and actually trying to row reduce and find an answer. So let's see. So we've got this matrix. Let me draw it nice and big. So we've got the matrix 1, 0, 2, 2, 9, 1, 3, 0, 1, 4, 1, negative 1. Okay. And we are trying, we want this thing to become 0, right? We want this thing to go away and to never come back. So we need to figure out what it is that we're going to do. And probably the easiest thing is, especially when you have ones and leading ones, you really want to use those rows, right? Those are kind of the best rows to do. So row operation to me that immediately kind of stands out is that if I want the thing that I've circled in yellow to become 0, what I'm going to do is I'm going to take -2 times row 1, because I've got this number 1 here, right? And I'm going to add it to row 2. And so you can see here, hopefully you see why because somebody, I can't remember who, but wrote, oh, gross in the chat, that you would write it like this. But hopefully you see kind of the way my brain works is I actually look at and I say, I'm going to add row 1 to row 2. What am I going to add, though? I'm going to add negative row 1 into row 2, or in this case, -2 row 1 into row 2. And I'm going to put that into row 2. Okay, and in fact, if you want, we can do it. If I do that, so if I do -2 row 1 plus row 2 into row 2, then let's see, hopefully, I don't think we were planning on doing this. I don't think we made the math work out particularly nice, but I'm going to get 0, 9, double check my answer here, -3, so then I get -8 plus 1, so that's -7, 3, 0, 1, -1. Okay. So hopefully everyone double check my thing. And then actually you tell me, so now let's say I wanted to keep going in my row reduction, which means I now want to get rid of this number. What operation should I do to get rid of that? -3R1 plus R3. Okay, does everyone agree with that? Or 1/3? Okay, so Ashton, you want to be careful here. 1/3 R3. Well, if I take 1/3 of that row, I'll be left with 1, 0, 1/3, -1/3, right? And I want that number to be a 0, though, not a 1. And, right, so that's, yeah, no, that's okay, right? Because we're figuring this out. So we don't quite want to take 1/3 of it. And we don't, obviously, I could just make it 0, but like that would just multiply everything by 0, right? Yeah, awesome, great. Now, where's your question? Of this lecture prior to Friday's test. I mean, it'll be posted where all it'll be posted where all of the videos are. So that's in the readings week, and I think some of your classmates answered that. Okay, great. Yeah. So Kayla, you wrote it as R3 minus 3R1. That's totally fine. And let's do it, right? Like we're here. Let's just kind of like finish that off. So let's do, and again, I just kind of write it as -3R1 plus R3. Just to kind of give you all an idea of what we're doing. So 1, 0, 2, 4, 0, 9, -3, -7. And then 0, 0, -3, -6, so -5, -12, so -13, like that. Is it possible to make an augmented, the question choice was 3R1 minus R2. Okay, so actually, Kevin, you bring up a great point. 3R1 minus R2 also works, okay? So 3R1 minus R2 is gonna work at, or minus R3, I think you mean, Kevin, right? You mean R3. 3R1 minus R3 is also going to work. You're going to get the same answer as me, but you will get instead, if you do that, you'll get plus 5 and plus 13. And that's okay, because the only difference between your answer and my answer is multiplying row 3 by -1. And we know that that is a valid row operation, right? So that those are still both valid techniques. So Kevin, if you want to do that, absolutely, that is okay. You will get a correct answer that way as well. Okay, so don't matter at all, right? And yeah, it doesn't matter whether it's positive or negative. Have I already posted a record of today's lecture? I mean, we're currently doing today's lecture, so I'm not certain how I could have posted a. Oh, I'm the recorder for this week, so no, this is the recorded lecture. It's not quite. So Haysam asks a great question. So is this in REF? Not quite, right? And why isn't it in REF? This is a great question. We're not quite there. We're almost there, but we're not quite.
The leading ones are not there yet.
Right, because we don't have leading ones. Exactly,
Yeah.
exactly. So these things, remember, to be in REF, these have to be leading ones. So now all we have to do is turn them into leading ones. And how can I do that? What row operations am I going to do to make those numbers into ones?
Row 2 multiplied by -1/9.
Okay,
Wait,
so
1/9, sorry.
1/9, right?
Yeah.
Okay, so 1/9, row 2 into row 2. And then for row 3?
1/-5.
Exactly, great. And Yiding, you got this in the chat too. So -1/5 row 3 into row 3. And so you can start to see now we're going to have these like nasty fractions. And this is kind of part of what I'm talking about in terms of, you know, a computer might do things differently than how we would. And positive 13/5. Right? And there we go. So now we're in row echelon form. So Kevin, the question was, you're given this matrix here that's at the top of the screen, and you want to make this 2 into a 0. How can I do that? Okay. So is everyone okay with this? And kind of we went obviously a little bit, isn't a leading one just the first non-zero entry? Yes, but it has to be a 1, right, Haysam? So the first non-zero entry here are the leading positions, but these need to be, oh, -9s, thank you, Kayla. These numbers, these are the numbers in the leading positions, but they need to be 1s, right? Part of the definition of row echelon form is that the first non-zero number in each row has to be a 1. So it's just about in row echelon form. The only reason it's not is because those numbers aren't 1, but of course it's a very easy step to make those 1 where we just kind of rescale each of the rows. Okay, perfect. And now here's another question. Is this in reduced row echelon form?
Nope.
Why is it not in reduced row echelon form?
Because the column 3 needs to have zeros above it.
Exactly, perfect. So it's not in reduced row echelon form because the rule for reduced row echelon form is each of the leading ones, right? These are the leading ones. Each of the leading ones has to be the only non-zero thing in its column. Now, in this column, great, it's the only non-zero thing. In this column, great, also the only non-zero thing. But in this column, not great. There definitely is still non-zero things there, right? Exactly, exactly. R1, 2, R3, they need to be zeros. Perfect. So actually, let's just kind of like finish this off without actually doing it because the fractions are going to be terrible. But now what row operations could I perform to finish this off and get this into row echelon form?
Multiply row 3 by +1/3 and -2 and substitute for respective each one.
So what was that? So negative. So 1/3 row 3 plus row 2 into row 2.
Yep.
Yeah,
Wait,
phenomenal.
yeah.
And then for the next one,
it would be -2 R3 plus R1 into row 1.
Great, perfect. Yeah, absolutely. And that works out great as well. Okay. I mean, alternatively as well, something else that you could have done here if you wanted to. So you could have done like 3 row 2 plus row 1. That also, you know, would have got into, you know, row 2. Actually, sorry, that one doesn't quite work because it does get rid of. So here's what I'm saying about kind of like the weird way of things. So this is a nasty fraction, right? So alternatively, what you could have done is 3R2 plus R3. But if you do this, you destroy this leading 1. It doesn't become a leading 1 anymore. It becomes a 3. So then what you would do is you would rescale that row by 1/3. And that would be a totally okay thing to do in order to avoid fractions until the very end, if that makes sense. So you can do all sorts of these things, and typically you want to avoid introducing fractions because fractions are quite messy, but there are lots of things that you can do in order to avoid the fractions and then only worry about the fractions at the very, very end, okay?
Prof, quick question.
Yeah.
Let's say there were rows and columns consisting of the first row being 1, 2, 0, 0.
Okay.
The second one being 0, 0, 1, 0.
So 1, 2, 0, 0, sorry, say that again.
Oh, the first row being 1, 2, 0, 0.
First row, 1, 2, 0, 0.
Second row being 0, 0, 1, 0. And the last one being 0, 0, 0, 1.
Mm-hmm.
Would that be reduced to row echelon form?
Okay, you guys, you tell me, is that reduced to row echelon form?
Well, I would say yes, but just the 2 is bugging me, that's all.
But so it doesn't say anything about the 2, right? Like, so reduced to echelon form says the only thing you have to do is worry about the leading ones. And so something like this is a great point though, and a great question to bring up. That doesn't, right? That because there's no leading 1 in that column, that 2 is allowed to be there. It's absolutely allowed to be there.
So it's still in RREF.
It is in RREF, yeah.
All right.
Okay, Nair, you asked me to keep checking your last message. I think both I and your classmates in the chat have actually answered your thing, but if you want to hang around after class, we can talk about it. Okay, great. Yeah, so is everyone okay with this? So I know that 2 bugs you, and this, like I said, this is kind of a great question to bring up. Absolutely, when you're looking at REF, you're only looking at the position of the leading ones, okay? So that's important. And when we actually take now these systems in reduced to echelon form and write out the answers for them, you'll see why that's kind of so important. Can you show the answer again? So Batuhan, I'm not certain what you're asking. What answer do you want? Nair, let me talk to you about this after class because we have answered this question a couple times now.
Hello, Professor. Can you go back to the poll just for like a quick 15 seconds?
Go back to the what, sorry?
The poll question?
Oh, the poll question. So the question itself, you mean?
Yeah.
Sure. So, I mean, we went far beyond what the poll question was asking, right? Like, okay, right? So we put the entire thing into reduced row echelon form.
Yeah, that's why I was confused because it said R2 minus 2R1.
Yeah, so we did do that, but then we went a little, right? So we did that right. So R2 minus 2R1 is this, right? I just wrote it. Remember, we can put them in any direction we want, right? So R2 minus 2R1, that's the same thing, right? So that's technically the only thing we had to do, but some people, you know, just to kind of emphasize how do we actually put a matrix into reduced row echelon form, we went a little bit further and we did a couple of more steps just to give us a little bit of practice as to how we'd actually go through that row reduction. Will we do one more question? Ian, I'm not certain we're gonna get time for it, unfortunately, just because it is 5:58 already. But you know what, here's the thing, on Thursday, of course, we can do more questions as necessary and kind of eat into our reading time. That's okay. Oh, right, Octave. So for those of you who kind of want to see Octave quickly, let me do this. Let me just double check that you're still seeing the right thing. Okay, so, oops. So the Octave I use is going to be a little bit different than the Octave you use. So I use Octave in a command line interface, but it's pretty much exactly the same way. Okay, so your interface will look a little bit different if you use a GUI, because I assume that most of you don't use command line interfaces, but the syntax for how you define a matrix is exactly the same way. Okay, so let's say that in fact we had that matrix that I just had. Here's what I'm going to do. I'm going to use the square bracket to indicate that I'm starting a matrix, 1, 0, 2, 4, and then I'm going to use a semicolon to end a row and start the next row, 2, 9, 1, 1, and 3, 0, 1, -1. Okay, Yinchi, this is Octave. And you can actually kind of like see the name for it right here. This is a free online or a free open source software that you can download. Now, if you download this in Apple or Windows, your interface is going to look different from mine because the way that I run this interface is like as if it's on a server, right? So I don't have a fast. Yes, I do use Linux, And in particular, I use I3. So my system is going to look very different from any of yours, but the syntax is the same, okay? So you just write all your numbers with spaces in them, and then use a semicolon to say I'm going to start a new row. So you can see that when I hit enter, it produces this matrix here. And this is the matrix that we were just talking about. Now to put this in RREF, literally the only thing I have to do is type RREFA, and boom, there is the system in reduced row echelon form. Okay, and in fact, so now we can actually just read off the solutions to this linear system. The answer is x is negative 1.2, y is equal to 0.88889, and x3 or z is 2.6. Okay, so it's just like that. There are all sorts of crazy other things you can do. So again, if you kind of want to, so for example, if I just want to pull out the coefficient matrix of this system, I can do something like this. And then that way, if I want to change the constants, I can do things like this. Oops, I called it C, I guess. So this is a pretty powerful system that you can do. And of course, you can, like this thing can do 1,000 by 1,000 matrices very, very quickly. But in terms of solving a matrix system, it's very quick and very easy.
What about an augmented matrix?
So actually, this is an augmented matrix. So the matrix A that I've written here is augmented. Just the fact that that vertical line isn't there doesn't matter. When you put it into reduced row echelon form, it's implicitly treating that last line, right? Like if this was just a matrix without that line, their reduced row echelon forms are exactly the same.
Oh, okay. So you're just basically writing down the row.
Yeah, exactly.
That line.
Yeah.
Okay. Oh, yeah. And the semicolon shows that you're starting a new row.
Yeah, the semicolon says, yeah, you're starting a new row. Yeah.
Okay, thank you.
No problem. Daniel, yeah, this is GNU Octave. Yeah, sure, we'll get onto the technical points of whether I'm a hacker or not. But yeah, so Octave is super powerful. It's free. If any of you are familiar with MATLAB, it's the open source alternative to MATLAB. This is what I use because it's fast, it's free, and it's efficient. And it scales very easily. You can run it on computational servers, which is something that I occasionally have to worry about. I think you do have to download it, Mehdi, so it's not going to be something that, but it's pretty easy to download, and it's a fairly well-known common program. If you want to do, the advantage of this is if you lose the internet, you can still do your problems, right? Because it's running locally on your system. Are there any practice tests to prepare for Friday? So Ashton, we don't have any practice tests set up. If you go through actually the exercises at the end of each section though, what we do have is all of the previous term test questions from other years are already in the exercise notes for the questions. Previous tests though aren't gonna be useful because the way that we ask you to write in-person tests is very different than how we ask you to write remote tests, right? So we don't wanna necessarily guide you down the wrong path, but nonetheless, those questions are actually in the exercises at the end. Nair, sorry, let me make sure that I've answered your question, and it was in the chat. Nair, we're doing I'm recording this week, so I'm the prof who's recording. We're obviously doing the lecture now, so it hasn't been posted yet, but you can find the postings. Can someone throw in the chat? Well, here, I'll close my terminal.
Sir,
yeah.
Yeah, Tyler, I know where to find all the recording.
Yeah,
I know it. But the thing is, like as I told you before, like we have some internet-related blog in our country. We had like for a few hours.
Yeah.
And it's because of this military emergency hours.
Sure.
Because of ongoing situation in our country, so I was able to. Access the lecture only at like 5:59